joining us today. I've got this great panel of experts here to talk to us about certificate of analysis at RiskScout. We get a lot of questions from our financial institutions and other people asking, what exactly they should be looking for on a certificate analysis. And so today I brought in two groups of experts here who have been in this industry quite a while, kind of pioneering it. One from a science perspective, lab perspective, and then a lawyer perspective. So we've got Rod Kite here with Kite Law Office, and then we've got Chip and Stephen from Abundant Labs. And I'm Kristen, I'm the Director of Compliance at RiskScout, so we are going to rock and roll right through this. So with that, Rod, I'm gonna turn it over to you, and if you'll get us started.
Yeah, thanks, Kristen. I'm happy to be here. Today, we're going to be talking about, from my perspective, legal implications of hemp, what hemp is, specifically pre-harvest, post-harvest, and some things to consider with respect to certificates analysis. So I'll jump right in. Hemp is governed in the United States at the federal level by the 2018 Farm Bill. That being said, states, Indian tribes, and U.S. territories may regulate hemp production within their jurisdictions if they submit a plan that's approved by the USDA Secretary of Agriculture. As of this date, we have several states that have submitted plans. Most have been approved, a couple have been sent back for revision. In the states that have not submitted plans, those states' hemp production will soon be regulated directly by the USDA. Importantly, the Farm Bill provides that states may not prohibit interstate transport of hemp within their borders. In other words, they may regulate production and impose limitations and restrictions and guidelines and so on and so forth, but they may not prohibit the transport of hemp through their borders coming from one state to another. It's also important, and I'm going to touch on this a little bit later, but the USDA only regulates hemp production, which essentially means cultivation. It does not regulate post-harvest materials such as smokable hemp and CBD products. If you can move to the next slide, thanks. Total THC, I think, is a very important concept to understand. There's a lot of confusion about total THC in the market right now. Although not found in any federal statute or rule, the phrase total THC is a quasi-legal term. It's been adopted by the hemp industry for several years now, and it refers to the total potential delta-9 THC content in a hemp sample. Delta-9 THC is the cannabinoid. There are hundreds of cannabinoids, or at least over 100, in the hemp plant. Those are the primary compounds that are used therapeutically, that are derived and used in the oils and cosmetics and so on and so forth. Delta-9 THC is the one that is notorious for getting you high. It has a psychoactive effect. To determine the potential total delta-9 THC in a sample, the concentrations of delta-9 THC and also tetrahydrocannabinolic acid, also known as THCA, must be taken into account. This is because THCA can convert to delta-9 THC in a chemical process called decarboxylation under certain conditions, including when it's subjected to heat. If you can change, thanks. It's very clear from the USDA rule that pre-harvest hemp must account for total THC. Under the USDA's final rule, which was published in March, a hemp crop is deemed to be compliant. In other words, it's lawful hemp if it's tested no more than 30 days prior to being harvested using a post-decarboxylation method, and the results show that the delta-9 THC value does not exceed 0.3% on a dry weight basis. Under the rule, the post-decarboxylation value for THC is synonymous with the total THC in a hemp sample. And for this reason, it's absolutely clear that pre-harvested hemp is not compliant unless its total THC concentrations do not exceed 0.3% on a dry weight basis. That being said, and this is where a lot of confusion comes into place, total THC is not applicable to hemp which has been harvested. Now, provided that a pre-harvest hemp crop has been deemed to be compliant under the USDA's final rule, in other words, its total THC is no more than 0.3% on a dry weight basis, it may be harvested. Thereafter, and importantly, the USDA has no further jurisdiction over the hemp crop. The only other agency expressly granted authority to regulate hemp under the Farm Bill is the Food and Drug Administration, the FDA. The FDA's authority picks up where the USDA's drops off, namely at the post-harvest stage for hemp that's intended for human or animal use. The FDA has not, as of the date of this recording, promulgated any rules related to hemp or THC concentrations. It hasn't really adopted any rules whatsoever about hemp as of this date. The sole authority on post-harvest hemp falls back on the Farm Bill itself, the statute that Congress enacted. And its definition of hemp specifically defines hemp in terms of its delta-9 THC concentrations, not its total THC content. So that may beg the question, though. You say, well, okay, if a crop has been determined to be compliant pre-harvest, in other words, its total THC is no more than 0.3% pre-harvest, well, then wouldn't that automatically mean that its post-harvest total THC values also are within 0.3%? You may be surprised to find that that's not always the case. And there are at least 3 reasons for this, and I think it's important to understand them. First, the USDA final rule mandates that a hemp sample be taken, quote, approximately 5 to 8 inches from the main stem, including the leaves and flowers, the terminal bud that includes the end of a stem, or central cola, which is the cut stem that can develop into a bud of the flowering top of the plant. So this includes plant material such as the stalks and stems that contain only minimal concentrations of THC. Cannabinoids, which includes THC, are primarily concentrated in the hemp plant's flowering top and buds. The leaves contain some cannabinoids, but they're less concentrated than in the flowering buds. And the other parts of the plant do not contain meaningful quantities of cannabinoids at all. Thus, a hemp plant with flowering buds that have a total THC concentration in excess of 0.3% can still be compliant since the buds are ground up and mixed in with other parts of the plant that do not contain THC to form a test sample. So in effect, the other parts of the plant actually dilute the THC concentrations in the bud when the sample is taken, thus resulting in a compliant plant. Now, if that plant is then harvested for the purpose of selling the flowering buds, well, then the stalks, the stems, and the leaves are all removed, leaving the portion of the plant with the most concentrated levels of cannabinoids, including THC. And pursuant to the Farm Bill, these buds must not contain delta-9 THC levels that exceed 0.3%. However, they're still lawful since they are the post-harvest product of hemp, which was deemed to be compliant by the USDA final rule, and they meet the Farm Bill's definition of hemp. The second way that total THC levels post-harvest could be above 0.3% for a plant that tested below 0.3% pre-harvest is that the USDA final rule provides a 30-day harvest window. So this means that a hemp crop must be tested for THC concentrations within 30 days prior to harvest. And during that window of time between testing and harvest, a hemp plant's cannabinoid concentrations, including THC, continue to increase. And for this reason, pre-harvest hemp, which has been tested and determined to be compliant, may have total THC concentrations that exceed 0.3% when it's finally harvested. Provided that this hemp crop is harvested within the 30-day window, it is lawful. And then a third reason is that each hemp plant is unique in terms of its particular traits, including its concentrations of cannabinoids. So pre-harvest testing is mostly randomized in terms of which samples are taken from a crop. So accordingly, it's possible for the particular hemp plants that were chosen for testing to contain total THC concentrations within the 0.3% limit, while other plants in the same crop have total THC concentrations that exceed 0.3%. Now, since compliance testing is done for the entire crop, this can include a field, a greenhouse, or an indoor growing room, and not per plant. The individual plants within a compliant crop with total THC concentrations in excess of 0.3% are themselves compliant. And this is because they're part of the crop which has been determined to be compliant. Okay, you can switch slides now. Thanks. And I think it's also really important to understand that THC in hemp is not a controlled substance. This is, and specifically tetrahydrocannabinols in hemp are not controlled substances. The only form of THC that's actually referenced by name in the Farm Bill is delta-9 THC. So delta-9 THC is lawful in hemp when its concentrations do not exceed 0.3% by a dry weight basis. All other forms of THC in hemp, including THCA and including delta-8 THC, are expressly removed from the Controlled Substances Act and are not controlled substances regardless of their concentrations when they're in hemp. Okay.
So I'm Chip Miller with Abundant Labs. I've got Stephen, our Chief Science Officer here. He's still trying to figure out where the camera
There
is. So, and what our purpose for being on this call is to give you some ideas of how to look at a certificate of analysis and what exactly are you looking for when you're looking through it. So the first thing that everybody gets awestruck with is the fact that there is a lot of information on a certificate of analysis. And when you look at a certificate of analysis, it's important to understand why you're looking at it. In this context, we're trying to figure out if the plant that we're receiving or the products that have been made are in fact legal or we're able to receive and use them. So as Rod said, there's a lot of I wouldn't say subjectivity, but there's some gray area in there with regard to what is legal and what isn't, with regard to how everybody is interpreting the rules. So what we do is we focus specifically on what we call the cannabinoid testing on a certificate of analysis. Included in the certificate of analysis, you'll find, and we'll talk about in a minute, a number of other areas that are very important for people to look at when considering using hemp, especially when it becomes an ingestible. So we look at the cannabinoids. As Rod just said, there are well over 100 different cannabinoids in the plant. The most well-known are both the CBD and THC. For purposes of production, for us, we're very interested in the CBD content. We are interested in some of the other minor cannabinoids, depending on what our client might be looking for with regard to production. And then we're very interested in the THC, some with regard to some of the creative recipes that our clients have, and then also when we're putting products out into the market for our clients, making sure that those products meet compliant rules that are out there. So, as Rod was talking about, the big things that we look for is how much THCA is in the product, and then how much Delta-9 THC. And depending on what rules are applied to those products, whether the flower coming in or the final products going back out, we concern ourselves with total THC as well. We wanted to provide a standard formula that's used to figuring out your total THC. So if we have a client that's only concerned about the Delta-9 THC, it's real easy, and we'll see this in a minute on the analysis to identify that. If they're worried about total THC, then they have to decarboxylate the product, and that decarboxylation process basically allows the A in the THCA, the CO2, to be released. We mostly know this by using a lighter and heating the product, and you see that a lot through consumption. We liken it. We tell people it's the difference between eating the flower or burning it. You can eat flower that potentially could get you high, and it wouldn't get you high because you're not releasing that CO2 and your body metabolizes it differently. Once you light that flower and decarboxylate it, you release the CO2, and thus the body metabolizes it differently. And then from a standard of other panels on the test, on the analysis, for purposes of most people, the important thing is to look at whether or not they've been identified by whatever agency has controlled that area, whether it's pesticides, heavy metals, microtoxins, whatever you're testing for. They'll typically tell you if it's pass or fail. They will give you some of the detail, but for purposes of most consumers and frankly within the banking industry, it's important to know whether or not those anything has failed. If it has, then it's you need to do a deeper dive to figure out what exactly it was that failed. And then last, when we look at these analysis, we take into consideration, most importantly, when it's tested as well. We want to make sure that the testing of the material wasn't a year ago. because there is the possibility that that product, whether it's a plant or finished product, has degraded in some way. So we'll bring those tests up to recent date if needed. So the next slide. So here's an example of two tests that are very important for us in this situation is cannabinoids. You can see on the left side, this is a certificate of analysis. Like I told you, there's a lot of information here. For our purposes, again, we're interested in that CBD and CBDA. And this is actually what we would consider a good flower for our purposes. Because it's you can see the total CBD content is up over 10%, which is what we typically see for compliance in our QC. You'll also see on this certificate analysis very clearly stated the delta 9 THC, which is 0.134%, below that 0.3% that Rod was talking about. So therefore, we don't concern ourselves in most cases with this. If we have a need to understand, whether it's for federal law or our customers' need to what the total THC is, then what we do is we go, as we're showing you down here in the bottom in the red, that we use the formula. We take the THCA, assuming it's decarboxylated, remove that CO2, and then add the delta 9, and this gives us our total THC. So some might look at this and say, well, that's that material's hot, or it's over the 0.3 limit. For our purposes, depending on when we received it and what our uses have been of it, will depend on whether or not that product's legal or not. And then on the right, this is another form of a certificate of analysis, but more importantly, it's a report from the in this case, a state Department of Agriculture, North Carolina, and this is telling us that the flower that we are receiving is legal. It gives a final report and it lists the total delta 9 THC at 0.18, which in the state of North Carolina, for purposes of this of that harvest, that was a perfectly legal product and one that we want to be able to we would want to receive. Okay. So getting into the third-party testing, I want to introduce again Stephen Nerlich to let him talk more on the science side of the needs with certificates of analysis.
Hey. Thank you, Chip. Thank you, Rod and Kristen. So with third-party testing, that's where it all starts for fiduciary responsibility for a bank or for a company and for true regulatory compliance. A lot of labs have in-house analytics like we do, but I would not consider that at the level of a fiduciary responsibility just because of the standardization that goes into accreditation. So lab accreditation for third party, it should list an ISO standard. So the 17025 is the ISO for laboratory, and that goes into the way that the machines are calibrated, the routines that go into that, to make sure that from a legal standpoint that it's again the most accurate kind of lab that you can have. Tests required domestically. Most domestic producers of finished goods are looking at potency, residual solvents, because the industry uses a lot of solvents in the preparation of and extraction of the cannabinoids, and then heavy metals. The international markets tend to require more, and also larger manufacturers. Like in the future, as this market expands, Costco's and Walmart's and Walgreens and things like that are going to be more interested in a wider variety of testing, pesticides, herbicides, bacteria and mold, and then also the mycotoxins. And we'll go into these in a little bit. And then the other thing to look at when you're looking at a COA is what are the limits? So when we're talking about, we know the THC limit, but when you're talking about herbicides, pesticides, and especially residual solvents, that can vary state by state based on an individual state's agricultural department or food safety types of regulatory agencies. So vary a lot state by state, and California, Florida, Washington, and Oregon are typically what the COAs that I see are referencing when they're referencing a standard that they're going by, or an action level that would denote a pass or fail. Okay, next slide. When we're looking at the cannabinoid potency, again, we're talking about measuring the amount of a cannabinoid present. The contractual obligations laid out in a sales order would determine what the CBD concentration is. Distillate can vary widely from, say, the low 70s up to the up to the mid 90s. So you want to make sure that product specification sheets are clearly stating what a producer is delivering into the market, and that the COA clearly shows that that's being met. There's also other minor cannabinoids, CBG, CBN, THCV, all these different minor cannabinoids. They are important for efficacy domestically, but internationally there are certain prohibitions against some of these minor cannabinoids. In Europe, you're not allowed to have CBN. And in Japan, you're not allowed to have any THC. So it really becomes a more nuanced sort of look at these certificates of analysis as you expand the market. The instruments used depends on the test. For cannabinoids, the typical one is HPLC, or with a UV detector, or a PDA, which is also a light-based detector. Or there's an LCMS. The MS stands for mass spectroscopy, which is about 100 times more sensitive than the HPLC. And this is important, as we'll get into later when we talk about levels and what non-detect means. And these methods are often unique to the hemp and cannabis industry, whereas other analyses like residual solvents and heavy metals are fairly standardized due to the EPA. They have extremely specific methods that are used for analysis and for sample prep. So that's actually very standardized across multiple different industries. So residual solvents, again, the extraction and processing typically involves a lot of different solvents. Among them, ethyl acetate, heptane, pentane, and hexane. These are measured in the parts per million, or ppm, and the analysis is performed on a gas chromatograph with an FID detector, or flame ionization detector. And again, these are federally standardized analysis, typically found in many like water quality or other food safety labs. Heavy metals. The metals can be brought into the hemp plant through absorption from the soil, which is the roots are very good at absorbing metals from the soil. And then also from equipment or solvents, or the mechanical processes being involved in the extraction and processing. The metals tested vary from lab to lab. There's a standard suite of metals, but they do sometimes vary between labs. And so that's something that, if there's a particular metal that a customer is interested in, or a state regulatory agency, that's something that might determine which lab you're going to be looking at for a COA. And again, they're fairly standardized and reported in parts per billion. The analysis is performed on an ICPS, which is an inductively coupled plasma mass spec. So it's just a very fancy name for, basically it's just looking at atomic absorption and things like that. And it's looking at individual elements, again, like the metals, cadmium, zinc, mercury, things like that. Next slide, thank you. So pesticides and herbicides, sometimes used in the farming of hemp, or it could be in the water table, could be in neighboring fields. There are too many varieties to test. So you'll commonly see a very similar set of 40 to 60 that are typical on a COA, but they do vary from lab to lab. And so again, if there's a particular interest or a particular regulatory hurdle that you have to meet, then it becomes important to look at the exact chemicals that are being listed on the report. Here it's done by LCMS. Again, that's the most sensitive way to measure things, is with a mass spec. And that's, again, fairly standardized across all industries, because this is something that's used in environmental testing and food safety. And the results are reported in parts per billion. Mycotoxins. So this is looking at the presence of mold toxins. So you can have mold present, but it's not, sometimes you can see the mold, but it doesn't produce mycotoxins. Other times you don't see any evidence of the mold, but the mycotoxins are present. So this is, as we learn more about the effects of mycotoxin, that's something that could be either regulatorily stipulated, or customers themselves would be very interested to know if there's mycotoxins present. And again, it's measured in LCMS parts per billion. So as an industry, we lack standardized testing methods, and then LOD and LOQ. So with testing methods, like with an HPLC, there's many different varieties of HPLC out there that work at different pressure ranges. They have different columns, different sensitivities, different wavelengths. You can change the wavelength of light that a detector is using, and it will drastically change the effectiveness of measuring certain concentrations of analytes. And there's no standardization. They should be listed. Things like the method that you're using, the equipment that you're using, the type of detector that you're using, even the wavelength of light should be something that's listed or at least available. So that gets into some of the variation that's being used. And then it even gets into sample prep. How long, what temperature, what types of solvents are you using? All these will affect your ability to extract the compounds out of the samples that you're looking at. And then again, other industries are standardized. And in those industries, they reference exactly what a very well-known method that's been published and accepted by, again, the EPA or the USDA as an accepted testing method. One thing you'll always see on a COA is an LOD versus an LOQ. So these are limit of detection versus limit of quantitation. So limit of detection means that you can detect an analyte, you know it's present, but it's in such a small concentration that you cannot consistently and verifiably measure how much is there. The LOQ is the level at which they can confidently measure the amount present. So the LOD and the LOQ varies as well. It not only varies lab to lab, and so you should see it listed on the report for each analyte specifically, what their level of detection is and what their level of quantitation is. So besides lab to lab, you even have variability within the lab itself. You can have different machines in a lab that have different levels of sensitivity due to age or just due to random fluctuation in an instrument. Or age of a column, age of a lamp on a particular instrument. All these things can affect the LOD and the LOQ. And again, the LOD and the LOQ should always be listed. So analytical does not mean absolute. So we were just talking, I just mentioned that there's variability. So in a detector, in a certain detector on a machine, it might have a lamp that's aging. And so its sensitivity is going to go down, or it could, as it ages, it fluctuates with the strength of the light that it's emitting. That can affect the reading that you're getting. And so if you're failing a test, like that, you might want to have a retest or something like that because there is variation. So analytical lab results can vary as much as 10 to 20% very easily. And it's the same answer, right? And that's something that people that aren't analytical chemists, it's hard to wrap your head around. But there's something called confidence intervals and standard deviations. And so on certain tests, 90 is the same as 82, that those two answers are the same answer because they both fall within the 95% confidence interval. So where does this variation is coming from? So each piece of equipment has a natural error range in it. You're weighing samples. You're measuring a volume of solvent to dilute that sample in. You are then, through a series of iterations, pipetting or volumetrically measuring and moving from one tube to another, different volumes of that solvent. The temperature at which you're doing this can change the volume of the solvent. And so there's variation that gets introduced that way. And each time you're doing that, it's not exactly additive. It's actually like compounding in the area. And so you get this spread of answers that can come from a single sample. So now we can talk about LOD versus non-detectable versus zero. And so, it is impossible to define a product as zero THC. You have a lot of customers in the marketplace that want, I want a THC-free product. And the reality of the situation is there's just no such thing. The conversation with the customer is, you're not zero, you're non-detectable to a particular LOD. And so as instruments gain sensitivity or labs, can get better equipment, better processes, and better training, the LODs, which again is a statistical representation of accuracy and precision, those get narrowed and they get brought down. And so over time, LODs will be decreasing across the industry. And so a product or a process that's currently non-detectable to a certain level will become detectable given a higher sensitivity instrument or method that gets developed. So this becomes, again, a place where not only regulatorily, but especially when it comes to contracts and product specification sheets, what exactly are you delivering into a market as producers here? What are we delivering into a marketplace? What are the LOD levels that we will meet contractually? And what does it mean to be non-detectable versus zero versus what your level of detection is? And so that's important. You know, if a bank is looking at the contracts or getting involved in a deal of some sort, what is that stated in the contracts? Because that can avoid a lot of headaches later while you're then discussing the difference between LODs and different labs and how that can affect whether something is compliant or not. And just to show what variability really looks like in the real world. So this is 4 samples of a distillate sent to 5 different labs. And so in the upper, you see the exact answers that they got. In the lower table, you see the statistical analysis, the min and max. So the highest rating was 94.4. The lowest was 77.8. And so you can see with the 95% confidence interval at the bottom, 8.08, which is 2 standard deviations. The 84 and 77 are actually the same answer, right? Because they're within that. Yeah, but that's the truth. They're within the 95% confidence interval, so they are the same answer, right? And but 94 and 84 are not the same answer, although they're very close. So you see this. The range went from 77 to 94, which is about an 18% nominal variation. I think the coefficient of variance, another statistical method would say it's probably about half that. The CV would probably be about 7 or 8%, maybe 9% variation. But within the labs themselves, you can see that they cluster pretty well. Lab V there is 77 to 82. Lab X is 88 to 94. So you can see that those cluster within a lab fairly well, but that's the same sample being tested. Okay, and that's actually a very typical thing that you see in an analytical lab, is that all those are the same sample, all those are technically the same answer, except for like that 94.4, that's an outlier. But every other answer on that slide is the same answer, given a 95% interval of confidence. But they vary widely. And if you were a lab contractually obligated to give distillate at 80% and it's showing up at 77, it's technically the same, you're meeting it, but if that's not discussed or that's not clear for people that don't know analytical chemistry, that can then become, something that has to be mediated, and dealt with on an education level as to what it is that, these analytical results actually mean. And I think that's.
Yeah, thank you guys. That was really informative. I have to answer COA questions all the time, so this really helps me out. And it is mind-boggling to look at them because some of them are way more informative than others, right? So I think some good takeaways here to kind of simplify some stuff for the guys that are looking at it are pre-harvest. It's really important to look for the total THC value not to exceed 0.3, but post-harvest, that number only applies to the Delta 9. A best practice for bankers or anybody in the financial industry dealing with the hemp space is to request COAs for pre-harvest material and post-harvest finished products. And a best practice from the lab side is ensuring that you are dealing with an accredited lab. Make sure that your COAs are actually your real COAs for the products that you're using, right, guys? Or the products that your customers are planning to sell. So anything you guys would like to add?
I'll jump in go ahead, Chip.
Well, I was just going to mention one thing that we did cover up on the was the original COA was a lot of COAs now are referencing either an ID number or a QR code. And part of the reason for that is to protect against forgery. We're seeing in the market, there's because the market is fragmented from a commodity standpoint. There's not proper oversight for products that are moving. So sometimes we see certificates that have been modified to give a better result for a product. So so we do look for QC information using those QR codes, or even going online and entering an identification number to make sure that it looks that it's the same as what we're actually looking at. So.
Yeah, well, you know, Chip, I think despite the fact that we're currently in different countries right now and Zooming, we are clearly on the exact same wavelength, because I was going to say that exact thing. And since this is a risk issue, and it has to do with banks and looking at compliance, and frankly, anyone who's in the industry, unfortunately, as of this stage of development industry, we are seeing a lot of fraud and forgery. And so if someone presents a COA, don't assume that it's accurate just because it looks official. Don't presume that the QR code is going to match up with what you see on the COA. Very commonly, the name of the company will have been replaced with the name of the company that's trying to pass off this COA as theirs. And so I think it is really important to take the time to not only look at the numbers and make sure you understand them with the discussion we've just had, but also just to kind of follow the links and say, okay, well, if I click on this QR code, is it going to take me to a place where, you know, that matches all of the data on the COA? And if not, I think it's really important to call the lab and get some verification.
Good. Anything else, guys?
No, I think that you know, Stephen got into some real technical pieces of you know, what we're using and how we're using it. The really big issue in the market right now is standardization, as he was talking about, and we're learning more every day. And as labs do get in further detail, the biggest issue is going to be between those that are concerned about, you know, no THC and how much THC, and you know, we're finding that with a lot of our clientele is reaching out to us because those levels of detection that he was talking about are getting lower and lower, and they're finding stuff we didn't know was there before. So there's a lot more to come with the market, and you know, and I would tell anybody listening, find a good, solid advocacy group that you can join and be a part of, and support them in trying to develop out this industry.
Yeah, absolutely. I agree. And one of the things to think about and be aware of right now is we gave the overview from a from a federal standpoint, but state law differs from state to state. And right now, we really truly have a patchwork of different regulations and regulatory regimes throughout the country. And so, whereas I spent a lot of time talking about total THC with respect to pre and post harvest, there are some states that under their state laws will regulate post harvest products and have a total THC standard. So just make sure that you understand where your banking client customer is operating from and where it's selling into. So again, connecting all the dots to make sure that you've covered the federal, you've covered the state, and also that the science really matches up.
Yeah, good. Well, thank you guys. I appreciate it.